Next presentation, as I mentioned, is the title is Evaluation of Selected F6 Peanut Progenies of BC3-derived Introgression lines in Spanish peanuts for resistance to Aspergillus flavus infection. And our presenter this morning is Dominic Ndela.
Good morning, good afternoon, good evening to everyone, wherever you are. I am Dominic Ndela from University for Development Studies, Ghana, presenting on evaluation of selected F6 peanut progenies of BC3-derived introgression lines and Spanish parents for resistance to A flavus. This is my presentation outline. Peanut is an important legume crop which serves as food, a good source of protein, and also serve as income. Its production has so many challenges such as drought, the use of an improved variety, pest and disease. In addition to this, its quality has been declining due to A flavus infection at pre-harvest and post-harvest stages, which leads to aflatoxin contamination. Consumption of aflatoxin contamination product is unsafe or may be unsafe to the consumer if aflatoxin level exceed the acceptable consumption limit, which strategies and control management has been practiced to reduce aflatoxin contamination in peanut. In Ghana, we have standards. Standards have been set to regulate especially what human consumes. And in Ghana, we have official acceptable limit for peanuts, which is 20 ppb, but such standards are practically never enforced in our domestic markets. One of the most promising management techniques to minimize aflatoxin contamination is the use of genotypes resistant to A flavus infection and aflatoxin contamination, which peanuts are shown to be a good source of resistance to diseases. Aflatoxin resistance has been reported in some genotypes based on resistant mechanism to A flavus infection and aflatoxin contamination in peanut, which has been categorized into seed pod, granite, peanut pod, seed coat, and cotyledon. The objective of this study was to between Schubert's by the BC3 interspecific integration line 43-09-03-02 and TS32-1 by the BC3 interspecific integration line 60-02-03-02. These interspecific lines arose from the cross between Florunner by TxAG-6, where TxAG-6 is a synthetic amphidiploid developed by Dr. Charles Simpson. These BC3 population were evaluated based on resistance to leaf spots, where this population, interspecific population, 43-09-03-02 and 60-02-03-02 were highly resistant to A flavus, were resistant to leaf spots, which were used to cross with the Spanish parent in Dr. Macboro's laboratory. F1 to F3 were developed, and the F3 were brought to Ghana by Dr. Tenge, who advanced this population to F6 and selected the lines based on resistance to leaf spots. And I'm using these lines to see whether it will be resistant to A flavus infection or not. These are the population, and Chinese and Manipinta serve as susceptible check, and ICGV 0341401 serve as a resistant check. The study was conducted at Plant Pathology Laboratory, CSIR SARI, and in vitro seed colonization was done using Casno et al. 2011 and DM et al. 2018 methods. Inoculation was done on peanut with intact seed coat and peanut without seed coat using aflatogenic A-flavor isolate. Data were collected on incidence and severity of A-flavor infection on the seed and subjected to an overusing GenStack Discovery 12 edition. Means were separated using Tukey's HSD test. These are my finding I'm sharing. In figure one represents A-flavor colonization of selected peanut genotype with intact seed coat after inoculation, where we can see in figure 1C and then F, which had heavily infested with A-flavus infection. These are the susceptible material, that is Chinese, and then Manipinta, which we have here the resistance check with less infection, and the advanced breeding line, the F6 advanced breeding lines with less infection or with clean surface. We also look at the cause of the clean surface, and then we remove the seed coat from the selected genotypes, where we can see in figure 2, EF and gene, EF and gene with total colonization without the seed coat. This same genotype with clean surface, and this was taken on the 8th day after inoculation. This indicates the role the seed coat played in the infection of the A-flavus. Also observe variation between the genotypes for incidence and severity, which under the incident, we have our susceptible check, which is Chinese and Manipinta, and also some of our advanced breeding line having over 80% incident infection, both in figure 3A and then B, as we can see. And it was interesting to note that genotype 96, which we can see below this, our resistance check, having less colonization, having less incidence, and it even outperformed the resistance check. And also in the figure 3B, we can see line 29 having 29, Chinese and Manipinta having over 80% incidence, and then our resistance check, 2 lines below the resistance check were the advanced lines we evaluated, which had less and also outperforming than the resistance check. This observation was made in both incidence and severity, which under the severity, we still have line 96 and line 27B and 15A outperforming than the resistance check. This variation could be attributed to the structure of the seed coat, which was also reported by previous findings. They stated resistance to A-flavus was attributed to the thickness and permeability of the seed coat, and presence of wax and quitin layers also serve as inhibitors to A-flavor infection, and the presence of some polyphenol compounds such as thymine serve as inhibitors to A-flavus infection. Also look at correlation between incidence and severity, which we can see we have severity day 2 and incident day 2 having strong correlation of 95%, day 4 severity and day 4 incidence having strong correlation 98%, and averagely we have a correlation of 97%, which indicates that any of these parameters could be used to evaluate for resistance to A flavor infection. And this was also reported by GM et al. 2018. He had 93%, which is lower than our correlation. We had 97%. The presence of resistant genotype in this population signifies the existence of individuals within the BC3-F6 population that may have equal or stronger level of resistance than the Spanish parents used in developing the population under the study. And the identified peanut genotypes could be used as donors to A flavor resistance in any future peanut breeding intervention or released as peanut varieties for farmers to use in the future. Further study is recommended with the aim of quantifying aflatoxin accumulation in the genotype under the in vitro seed colonization using any analytical method. And evaluation should be carried out on the entire BC3-F6 interspecific introgression lines or population to identify new sources of resistance to breeding for breeders to use in future to use in the future. I would like to acknowledge USDA, National Institute of Food and Agriculture, Peanut Innovation Lab, CSIR, Savannah Agriculture Research Institute for Enabling Environment to carry out this research, and University for Development Studies for admission to pursue my master's studies. Thank you.
Thank you, Dominic. And we have time for questions. Or let me see if there's a question here from the audience. The question comes from David Okello. Did you subject these lines for ease of removing the testa? What about the agronomic performance of these lines in comparison with the current flagship varieties?
Please the question again.
Yes, sir. Did you subject these lines for ease of removing the testa? What about the agronomic performance of these lines in comparison with the current flagship varieties?
Okay, in my recommendation, I said this was done in the lab, so I recommend we should further screen these lines on the field. So screening this line on the field for aflatoxin resistance genotype, we can also look at the agronomic data to see its yield and the yield component.
Okay. All right. Thank you very much.